Supergiant flares from Crab Nebula, presented by Science at FXLance.com.
In 1054, nearly 1,000 years ago, a star in the constellation Taurus exploded. The supernova was so bright, Chinese and Arab astronomers saw it in broad daylight, and, according to their ancient records, it remained visible in the night sky for 2 years. The dead gaseous remnant of the star has been expanding quietly ever since. We call it the Crab Nebula. New observations show the Crab Nebula might not be so dead after all. On April 12, 2011, NASA's Fermi Gamma Ray Space Telescope and the Italian Space Agency's Agile satellite detected an enormous outburst of gamma rays, more than 30 times more powerful than the nebula's normal gamma ray output. On April 16th, it happened again. These super flares are the most intense outbursts we've seen in the Crab Nebula, and they are extremely puzzling, says Alice Harding at NASA's Goddard Space Flight Center in Greenbelt, Maryland. Harding and others think the flares are somehow connected to the Crab Nebula pulsar. At the heart of the nebula lies what is left of the original star's core, a superdense neutron star that spins 30 times a second. Each time it goes around, the neutron star sweeps a beam of radiation past Earth. It literally pulses us with electromagnetic waves, hence the name. For many years, these pulses were the only significant changes in the nebula's output of high-energy radiation. That's why the current outbreak of superflares is so surprising. The Crab Nebula exhibits high-energy variability that we're only now beginning to fully appreciate, says Rolf Buehler, a member of the Fermi Large Area Telescope team at the Kavli Institute for Particle Astrophysics and Cosmology. Scientists think the flares occur when the pulsar's intense magnetic field undergoes a sudden restructuring, a sort of starquake. Such changes can accelerate particles like electrons to velocities near the speed of light. The electrons, in turn, radiate gamma rays. To account for the recent flares, scientists say the electrons must have energies 100 times greater than can be achieved in any particle accelerator on Earth. This would make them the highest energy electrons coming from any known source in the whole galaxy. Dead star? Quiet nebula? Think again.
For more information on ScienceCasts, stay tuned to Science at FXLance.com.